For this section, we're going to keep working with quadratic equations. And remember that quadratic equations are when I have ax squared plus bx plus c equals 0. And a, b, and c are all constant. So if we take a look at our example right here, a would be 2, b would be 5, and c would be 3. And I'm going to factor these out again. But when I factor these type of quadratic equations where a is a number that's greater than 1, I am going to have to follow the rules of I'm trying to find something that has the sum of b, and it's also the product of a times c. So I'm looking for something with the sum of 5 because b is 5, and the product of 6 because a times c is 6. 2 times 3 is 6. So just starting off with my t-chart, again, I'm going to have my factors and my sum. So if I use the factors of 6, I have 1 and 6, which gives me the sum of 7. So that doesn't work. Then I have the factors of 2 and 3, which gives me 5. And that one does work. So I can rewrite my quadratic equation to say 2x squared plus a 2x plus 3x plus 3. So all I did was I rewrote b using my two factors that I just found. Using that grouping method that we learned in a previous section, I can group things that are similar together to help me factor. So I see that I have a 2x that's in common for this one. So I'm going to factor out a 2x, and I get 2x equals x plus 1, or times x plus 1, plus I can factor out a 3 because I'm trying to get x plus 1 inside the parentheses, x plus 1. And now I write something in parentheses like 2x plus 3. I'm using what's outside the two parentheses times my x plus 1, which was inside my parentheses, as my final answer. So let's go ahead and factor this trinomial. I'm looking for something with a sum of what b is, and b would be 29. And I need the product of a and c, and a is 7 and c is 4, so I need the product of 28. And if I was to make my t-chart with my factors and my sums, the factors of 28 is 1 and 28, which gives me the sum of 29. So I'm going to rewrite my trinomial to say 7x squared plus 1x plus 28x plus 4. I can use my grouping method. So I'm going to factor out an x from my first one. So I get x parentheses 7x plus 1. And I need 7x plus 1 again in my parentheses. So right here I'm going to factor out a 4. So I'm going to have plus 4 times 7x plus 1. And then using what's on the outside, x plus 4 times everything that's on the inside, so 7x plus 1, that becomes my final answer. Go ahead and pause the video, and I want you to try this one on your own. So I'm looking for something that is the sum of 13, and it has the product, and we're looking for, so our factors of what is 5 times 6, so of 30. So here's my factors, and here would be my sum. So I'm looking for factors of 30. So I can try 1 and 30, and that gives me 31 as my sum, and so I know that won't work. I could try 2 and 15. That gives me 17, which won't work. I could do 3 and 10, which would give me 13, and that one does work. So now I can rewrite my trinomial as saying 5x squared plus 3x plus 10x plus 6. And I'm actually going, because if I was to group now, I couldn't factor anything out but just an x here. And I still have anything right there as well. So I'm going to regroup. And I'm going to factor out a x from our first term. So I get x, 5x plus 3. And then the only thing that I could factor out from our second one to get 5x plus 3 would be a 2. So I would get 2, 5x plus 3. And then I combine my terms, so x plus 2 times 5x plus 3 would be my final answer. For this trinomial, I'm looking for something with the sum of -1 and a product of -2. So using my t-chart of my factors and my sums, if I had factors of -2 would give me -2 and 1, and if I added those together, I would get the sum of -1, which is what I'm looking for. So I'm going to rewrite, and I'm going to have 2n squared minus 2n plus 1n, because it's a positive 1, minus 1. Using my grouping method, I'm going to group together, and then I'm going to factor. So I'm going to factor out a 2n, and I'm left with n minus 1. And then on my second one, I need to factor out a 1 to get me to n minus 1 as well. So I'm going to have 2n plus 1 times n minus 1. Go ahead and pause the video, and I want you to try this one on your own. So I'm looking for something with the sum to equal -17 and the product to equal 60. So what are my products of 60, or my factors of 60? So I could do -2 and -30. And the reason why I'm doing both of them negative is because I'm looking for the product to be positive. And so this would just give me -32. And so that's not going to work. So let's try -5 and -12. And that's going to give me the sum of -17. So I can rewrite my trinomial to say 3x squared minus 5x minus 12x plus 20. Using my grouping method, I'm going to have x times 3x minus 5, and then I'm going to factor out a -4, and that way I can have a positive 3x minus 5. And now both of my insides match, so I have x minus 4 times 3x minus 5. Factor 4x squared minus 3x plus 5 if possible. If the polynomial cannot be factored using integers, write prime. So I'm looking with something that has a sum of -3 and the product to be 20. And when I look at my factors of 20 compared to if they make the sum, we can do -20 minus 1 is going to give me -21 as my sum. Another would be -5 and -4, which would just give me -9. And another pair of factors would be -2 and -10, which would give me -12. And none of these are giving me the sum of -3. So I can actually, none of these are working. So this one would be considered prime because I could not factor that.